Hello friends, welcome back to my YouTube channel Astin Padasale. So in this video, I'm going to discuss you the past year question that was asked from the analytical tool regarding to a GATE biotechnology syllabus. Okay. First question is match the following. So from analytical tools, mostly you'll be getting match the following questions only. So if you take this particular question, they had given the techniques and the important things that were employed in that particular technique. So first in real-time PCR we will be employing the cyber green, which is a cyanide dye that is used for staining your DNA. So real-time PCR in real-time PCR we will be using cyber green. So P is 2. So you can simply eliminate option A and option D. So you can consider option B and option C. Next is 2D gel electrophoresis. Okay, so in 2D gel electrophoresis we will be employing this amphalolytes. Okay, these amphalolytes will nothing but they can act both as an acid, at the same time they can also act as a base. Okay, so these amphalolytes are generally used in 2D electrophoresis. So Q is 4. So the correct answer is option number C. Regarding to affinity chromatography, in affinity chromatography we generally they will be employing the antibody linked Cephros beads for separating your various substances. Okay, so it is based on the affinity between the analyte and the substance being detected. So that comes under affinity chromatography. Next is microarray. So we all know in microarray we will be employing chips, so biochips. Okay, so correct answer is option number C. Next is regarding to technique. So we all know CD, circular dichroism spectroscopy, is employed for secondary structure determination. At the same time, CD is also employed for this conformational changes analysis. Also, they will be employing the circular dichroism. Okay, so P is 3. So you can simply eliminate all the 3 options, and the correct option is option number D. So X-ray crystallography and NMR are employed for your tertiary structure determination, and freeze drying is nothing but your lyophilization, which is concentration. It will be concentrating the substances. Next is ultra centrifugation, which will be employing the sedimentation coefficient. This method of ultra centrifugation is based on sedimentation coefficient. Okay. Next question. Protein-protein interactions are studied by. So you can expect this question in GATE 2024 biotechnology. So protein-protein interactions are studied by yeast-2 hybrid system, and at the same time it can also be studied by Western blotting, which comes under mass spectrometric technique. The next step after Western blotting is your mass spec. So both your yeast-2 hybrid system and mass specs are employed for studying this protein-protein interaction, whereas this DNA fruit printing is used for studying your interaction between protein and your DNA. And another technique is called as chromatin immunoprecipitation, which is also employed for studying this protein-protein interaction. So Q and S is the correct answer. So option B is correct. Next, protein DNA interaction in vivo can be studied by, so again it can be studied by this chromatin immunoprecipitation. Okay, so protein-protein interaction in vivo can be studied by this chromatin immunoprecipitation. In short form, it is called as CHIP, and the same CHIP method can also be employed for studying your protein-protein interactions also. Next is this chromatography and their elution condition. So first is ion exchange chromatography. In ion exchange chromatography, for separating the components, they will be employing increasing gradient of salt. So first they will be starting with the minimal concentration of salt, and then they will be increasing the salt concentration. So in ion exchange chromatography, by increasing the salt concentration, the molecules that are having a weak interaction will be separated first. Okay, it will be eluted first itself, whereas those molecules that are having a strong interaction will be requiring, they need more amount of salt concentration. So that's why in ion exchange chromatography they are employing increasing concentration of salt, starting from 1 to, and they will be keep on increasing, and then they will be, the salt concentration will be 100 microgram or whatever. Next, in hydrophobic column chromatography, which is based on hydrophobicity and polarity, they will be employing decreasing gradient of polarity. So they will be starting with a high volume, and they will be keep on reducing the concentration. Next, in gel filtration chromatography, they will be employing this isocratic solvent. They will be employing this isocratic solvents in gel filtration chromatography. Okay, so P is 3, Q is 4, and this R is 1, and again chromatofocusing. Chromatofocusing is again also a protein purification technique. It is also similar to ion exchange chromatography, and in this chromatography chromatography, they will be employing ampholites. At the same time, the only difference between this ion exchange chromatography and in the chromatofocusing is that in ion exchange chromatography, for elution, they will be employing increasing gradient of salt. Whereas in chromatography, they will be depending upon the buffer pH, they will be separating the component. Okay, so option C is correct. Next, in DNA sequencing, specifically in Sanger sequencing, using the chain termination method, the ratio of DDNTPs, that is dideoxy DNTPs to DNTP should be, it should be less than 1. Okay, so the ratio of DDNTP, that is if the denominator is DDNTP and denominator is DNTP, means it should be lesser 1. In other way, we can say the ratio of DNTPs to DTNPs should be greater than 1. Both are entirely different. Okay, so here in the question they are asking what is the ratio of DDNTP to DNTP. So the option correct answer is option B, it should be less than 1. Next, which one of the technique relies on spin angular momentum of photon? It is again your Raman spectroscopy. Next, in thin layer chromatography using a silica gel plate, a compound showed migration of 12.5 centimeter and the solvent front show migration of 18 centimeter. What is an RF value? What is the formula for RF value? Distance traveled by solute divided by distance traveled by solvent. So in the examination you will be confused whether solute comes above or solute comes below. So solute will be coming above. Solute should be above. Divide solute above and solvent is below. Okay, so this formula you need to divide, that is 12.5 divided by 18, you will be getting the answer. So distance traveled by solute in this problem is 12.5 and distance traveled by solvent is 18. So 12.5 by 18, what is the value you need to place over there. Next, which one of the following technique can be used to determine the structure of 15 kD? So you need to know 15 kilodalton globular protein at atomic resolution. The correct answer is NMR spectroscopy is used to determine the structure of globular protein, and NMR has few site restriction, like it can able to determine the structure of those protein whose molecular weight is ranging between 15 kilodalton to 25 kilodalton. And this is one of the most easiest question. In CSIR also they are asking this question. In DBT also I am asking this question. I'll be showing the formula sheet also. So here they had given us dicosan spectra of 3 protein P, Q and R, and they are asking which protein is alpha helix, which protein is holding beta sheet and which protein is holding a random coil. So circular CD is generally used for determine the secondary structure, and your alpha helix and beta sheet is coming under the secondary structure category. So this is the formula sheet. This is the CD spectrum of secondary structure that is present in the protein. So, okay. So simple formula I am telling you. So here, if you take the standard, you can able to find a W sign is there, na? So it is alpha helix. So alpha helix will be showing a positive peak. So the one above is positive peak at 193 nanometer and negative peak. It will be having two negative peak. One is here and another one is here. So alpha helix is holding two negative peak. One at 208 nanometer, another one is 222 nanometer. Regarding to this beta sheet, which is blue in color, it will be showing one positive peak and one negative peak. Positive peak is at 195 nanometer and negative peak is at 218 nanometer. So simply remember this graph alone. So W means it is alpha helix and it is somewhat N and U means, so consider this as an N and this as a U means it is beta sheet, and this full V. So this is a red color and random coil, and this random coil will be showing a strong negative peak as at 195 nanometer. So in this problem, it is showing W, so it is alpha helix, and it is showing one positive peak and one negative peak, which is nothing but your beta sheet, and this is random coil. Okay, it will be showing a strong negative peak. The random coil will be showing a strong negative peak. The correct answer is option A. Next, which one of the following technique can be used to study the conformational changes in myoglobin? So, conformational changes can be studied by your fluorescent spectroscopy. At the same time, it can also be studied by circular dichroism spectroscopy. So, the correct answer is option number C. So in fluorescence spectroscopy, it will be measures the emission of the light from a molecule after it is being observed. Okay, so if you take this myoglobulin, it is holding a heme. Okay, so heme is a light absorbing pigment, and it will be absorbing a light and it will be emitting the fluorescence. Based on that, you can study the conformational changes at various changes condition. Next is with regarding to the circular dichroism spectroscopy. So since myoglobulin is a chiral molecule, it can able to rotate the plane polarized, right? So based on that property also, you can employ the circular dichroism spectroscopy for studying this conformational changes in your myoglobulin, and also in your hemoglobin also you can study these things. Ultimately, you can eliminate this light microscopy, and mass spectrometry is also not being employed for studying this conformational changes. Specifically, conformational changes will be studied only by your fluorescence spectroscopy and your circular dichroism spectroscopy. Next, which one of the following technique can be used to compare the expression of large number of genes in two biological samples? The correct answer is DNA microarray. You can compare two samples. One is the normal condition, another one is a cancer patient sample. You can analyze them because in DNA microarray is a chip. In a single chip, you can able to run a different you can able to run a number of sample at a single stretch. Okay, so it based on the color representation, we can easily identify which sample which gene is upregulated, in which sample which gene is downregulated. So in large number, you can able to use this DNA microarray. Next is also a simple question, match the following question. So your infrared spectroscopy is employed for identifying your functional group, and the circular dichroism is employed for determining your secondary structure, and NMR is used for determining your 3D structure. Okay, so the correct answer is option number C. Again, I am telling you NMR, both your NMR and X-ray are employed for determining your tertiary structure of protein. NMR have size restriction, like only those protein whose molecular weight is 15 to 25 kilodalton alone can employed in NMR spectroscopy, and also in NMR they will be employing radio waves, because in CSER June to December 2023 they had asked this question, so that's why I'm telling you. Next is tertiary structure of protein consisting of alpha helix and beta strand can be determined by. It can be determined by your nuclear magnetic resonance spectroscopy. So tertiary structure means you need to simply click on nuclear magnetic resonance spectroscopy. And which one of the following nuclei is Earth? So it is a multiple select question. So again, try to know which of the following, which is an NMR nuclei, which is an NMR active nuclei, and which is an NMR inactive nuclei. Just try to know. So it is very simple. So here I had given you NMR inactive nucleus. Okay, so if you take this helium 2, carbon 12, oxygen 16, S 32, these isotopes are NMR inactive. So usually the correct answer for this question is option A and option B. So it should contain odd number of protons and neutrons. Only then those nucleus are NMR active. If you take these, they are even number. So they are NMR inactive. So now tell me what are the other NMR active nuclei or nucleus in the comment section. Okay. So next again in stationary phase they had given, and they are asked to match the corresponding chromatography. Sometimes the right hand side will be given the left hand side. Okay. So protein A is nothing but a substance that is isolated from Staphylococcus aureus, and it is widely used for separating your immunoglobulins. Okay. So this protein A is generally employed for in affinity chromatography. So A, just remember that particular thing. Next is Cephedex. Cephedex is used for size exclusion chromatography, which is also called as gel filtration chromatography. The phenylcephalose is used in ion exchange chromatography. The phenylcephalose is used in hydrophobic interaction chromatography. Whereas this diethyl aminoethyl cellulose, okay, it is nothing but it's an anion exchanger, and ultimately it is used for this ion exchange chromatography. Protein A, affinity chromatography. Cephedex, size exclusion chromatography. Phenylcephalose is employed in HIC, hydrophobic interaction chromatography. This diethyl aminoethyl cellulose is used in your ion exchange chromatography, and in this this diethyl aminoethyl cellulose, in short form it is called as DEAE. It is an anion exchanger. So in the comment section you need to tell me what about cation exchanger. Tell me any examples of cationic exchanger. Okay. Next, which one of the following spectroscopic technique can be used to identify all the functional group of an antibiotic. So simply they are asking which spectroscopy method is employed for determine the functional group. So we all know it is infrared. Okay, and there's another spectroscopic method which is nothing but your nuclear magnetic resonance spectroscopy. So both your infrared and your nuclear magnetic resonance spectroscopy are employed for identifying the functional group. Next, which of the following method cannot able to be used for determining the secondary structure content of protein? Okay. So it is very simple. It is nothing but your X-ray crystallography. So X-ray crystallography is generally employed for your tertiary structure, and here they are asking about secondary structure. So from that you can able to easily determine like your CD, IR, and mass spec. It can be employed for determine the secondary structure content of protein. Okay. So in the next video I'll be discussing the PYQs that was asked from immunology. That will be very much helpful for both for GATE DT and GATE Excel. So stay tuned.